Imagine sitting on a plane at 35,000 feet, flying nearly 900 kilometers per hour. You glance outside the window and notice the wing bending upward like rubber. It doesn't just move slightly, it bends dramatically like something is completely wrong. For a moment, it feels like the wing might snap at any second. But here's the strange truth. That bending wing is actually incredibly strong. In fact, if it didn't bend like that, the plane would be in danger. Once you understand why, you will never see airplane wings the same again. To understand this, we need to look at the massive scale of these machines. A single airplane wing can be longer than an entire professional basketball court. Inside it, there are fuel tanks holding thousands and thousands of liters of fuel. That same wing helps lift a machine weighing hundreds of tons into the sky. Now think about that weight being supported by nothing but fast-moving air. No pillars, no cables, just invisible forces keeping everything suspended high above Earth. It feels impossible, like balancing a heavy truck on two flexible plastic boards. Your instincts say those boards should be stiff, solid, and never bend at all. But here's where everything changes. Airplane wings are designed specifically to flex safely. Engineers didn't always believe this. Early designs focused on making wings completely rigid. They thought stiff wings meant stronger wings, which sounds logical in everyday life. But when powerful air forces hit those rigid wings, they didn't bend, they cracked. Instead of absorbing energy, they took the full impact and sometimes failed catastrophically. So engineers began searching for answers in a surprising place: nature itself. Birds had already solved this problem millions of years before humans ever flew. Their wings don't stay stiff. They bend, twist, and adapt constantly during flight. Instead of resisting the air, they move with it and spread forces evenly. That simple observation changed how engineers designed modern airplane wings forever. Now, to understand wing flex, you only need three simple forces working together. Lift pulls the wings upward as air flows quickly over and under them. Gravity pulls the entire plane downward, creating constant, opposing pressure on everything. And flexibility allows the wing to spread those forces safely across its structure. But here's where it gets even more interesting and slightly counterintuitive to understand. Imagine holding a ruler and pushing down hard in the middle with force. If it is stiff, it resists bending until it suddenly snaps under pressure. But if it bends smoothly, it spreads the force and avoids breaking completely. An airplane wing works exactly like that flexible ruler, just on a massive scale. As the plane moves forward, air creates lift that pulls the wings upward. That force curves the wing into a shape that actually makes it stronger. Instead of resisting stress, the wing distributes it evenly across its entire structure. So the bending you see is actually the wing handling stress perfectly well. But that's not the full story, because the wing doesn't just bend upward. It also twists slightly, and this twist controls stability more than most people realize. Imagine different parts of the wing adjusting their angle automatically during flight. It's like the wing is constantly correcting itself without any visible input. During takeoff, the wings begin almost straight as the plane starts accelerating forward. As speed increases, lift builds, and you can watch the wings slowly rise upward. On large aircraft, the tips can move several meters higher than their starting position. In turbulence, they bounce and flex repeatedly as changing air forces hit them constantly. It may look scary, but that motion is actually protecting the aircraft structure. Each time the wing flexes, it absorbs energy from the surrounding moving air. Instead of transferring that energy into the plane, it dissipates it through movement. It works like a shock absorber, smoothing out bumps just like suspension systems in cars. Most people don't know this, but airplane wings are tested far beyond normal conditions. Engineers push them upward until they bend into extreme arcs during stress testing. They go far beyond anything experienced during real flights, yet still do not break. Another hidden detail is how wings are built using layered materials and smart design. They are not solid metal, but carefully arranged structures that allow controlled flexibility. Some parts stay rigid, while others act like springs, storing and releasing energy smoothly. And here's something surprising. Completely rigid wings would actually make planes more dangerous. They would need more material, making them heavier and less efficient during flight. They would also struggle to handle stress, increasing the risk of structural failure. So that bending you see is not a weakness. It is the entire purpose. It is the result of decades of engineering inspired by nature and real-world testing. The next time you see a wing flexing high in the sky, remember this. Nothing is going wrong. Everything is working exactly the way it was designed. What looks fragile is actually incredibly strong and carefully engineered for extreme conditions. And once you understand that, the sight becomes less scary and more fascinating. You are watching physics, engineering, and design working together in perfect harmony. Now here's something even more interesting you probably never thought about before. If wings can bend this much without breaking, why don't airplane windows shatter midair?